The transit system, let's say the TTC or YRT, carries 24,800 riders per day, and they charge a fare of $1.85. The city hopes to reduce car pollution by getting more people to ride the bus, which maximizing the transit system's revenue at the same time. So it should be while. Little typo there. A survey indicates that the number of riders will increase by 800 for every 5-cent decrease in the fare. So by charging less, more people are going to be willing to get on the bus. But if you charge too little, then you're not charging enough and you lose money. So we want to maximize revenue. So we've seen a problem like this before, and on the y-axis we have revenue, on the x-axis we have fare decreases in this case. So here I have my revenue, and here I have number of fare decreases. So let's write that out. Let's define our variables. So let, not x, let R represent the revenue, okay, in dollars, and then let x represent number of price decreases by 5 cents. Okay, which is the same as $0.05. I think I'm going to stick with that second representation in this case. So here are my variables, my let statements. Now it's time to come up with an equation. So currently the revenue is given by, so if I go R, I have 24,800 riders, and the current fare is $1.85. So what's happening here? Well, I'm going to modify this equation because I know that if I decrease the price, I add 800 times the number I've decreased the price by. And that's the same. I have to modify this part of my equation in the sense that I have to subtract 0.05x. Again, for every decrease in 5 cents, I increase by 800 the ridership. This expression here, when multiplied out, yields a quadratic that looks like this. Let's see here. I get, I'm going to skip all the distributive property business and just go right to the final answer. I have 40x squared plus 240x plus 45880. Okay, so to find that maximum revenue, completing the square is in order. So let's begin. Factor out that negative 40. Then I have minus 6x, 45,880. Within the brackets, I am going to add 9, subtract 9, 45,880 again. X squared minus 6x plus 9. That negative 9 at the end, I'm going to bring outside the brackets, and therefore I have to multiply it by 40. It's going to be positive. Let me take a look here. So 40 times 9 is going to be positive 360. plus all this guy above at the end. There we go. Almost done. Negative 40. Complete the square. It'll be x minus 3 squared plus, and this is my final answer, 46,240. All this work just to get that maximum value, and this occurs at 3, 46,240. If I look at that on my graph, it is somewhere around here. Again, very rough sketch. Here's my 3 value. Here is my revenue. So, to answer the question, what fare will produce the greatest revenue? Well, I'm decreasing the fare 3 times by 5 cents. So if I have a fare of 185, I'm going to subtract 3 times 0.05, which gives me $1.70. Okay, because this here is 15 cents, subtract that from 185, and you get your price point. That's what you want to charge to get that maximum revenue. Okay, the second part, what the company transit system needs to charge to break even at $46,080. Just like something we've seen before, we're going to take that value, sub it into the standard form of the equation, which is right here, and solve for the zeros. So let me take that equation, just paste it, and I'm going to set it equal to 46,080. So 0, 8, 0. Bring everything over to my left-hand side, and that yields, all of this guy stays the same. And now I have negative 200 equals 0. And again, I'm going to try to factor this and see if I can just solve this by factoring, because everything seems to be divisible by 40. So I get minus 6x and then minus 5, sorry, plus, equals 0, and this looks nice. I know that if I have two numbers, x minus 1 and x minus 5, they add up to negative 6, they multiply to give me positive 5, so my roots are 1 and 5, which is perfect, which means I can either decrease my price by 5 cents, or just once, or by 5 times 5 cents, which is 25 cents. My prices are going to be, on the one hand, I have $1.80, and on the other hand, I have the price of $1.60. So those are my prices that will produce a break-even revenue.